now I'm going to present Mr. Viktor Mitev, who is going to tell us a little bit more of how to write a little bit better applications with TypeScript and to avoid many headaches that at some point in our life we all had. Viktor?
Thank you. Hello, everyone. I'm Viktor, and I want to thank you sincerely for your interest in our presentations today. I'm going to expand on the topic of how to develop JavaScript software more efficiently. For this, I'm going to focus exclusively on a tool named TypeScript. Before we begin, I'm curious, how many of you have heard of or have used TypeScript so far? Wow, a lot more than I expected, and I hope that you are able to apply it in action because it really helps us solve a fundamental problem. And the problem is that JavaScript is a dynamic language. And dynamic languages are hard to verify for correctness. We have to take our code and run it in a context to see if we get any errors during its execution. In a classical sense, that context is our client's web browser opening our website. But in my experience, I haven't worked on a web application where the following formula is not in full effect. Errors equal more code squared. Meaning that the more JavaScript code we write, the more errors that we're going to get. The main reason for this, I think, is that we really lack a standardized set of JavaScript development tools. Let me illustrate the statement. When we think about developing a Java application, we immediately think of using Eclipse or NetBeans to get the job done. For C#.NET applications, Visual Studio, no doubt. What about JavaScript? I, for one, can't think of a single standalone solution that can completely assist me in the development phase. And even if I do, the person next to me is going to have a totally different idea of how to get this done. We are then put in the ultimately dangerous situation where we develop JavaScript with no tools at all. We run the increased chance of having silent but deadly errors show up in our code. And these errors can get through multiple cycles of testing, deployment, and be discovered only after we have deployed a production version. This process can take up to several months, and the people in management are going to react like this.
Why can't we make what we want to make the way we want to make it? Why?
Because we haven't sought a solution. I'm a bit at a disadvantage here because Andrei already showed us many valid solutions in the previous presentation, and he also mentioned that TypeScript might be one of them. Because what we need is, I think, compiled JavaScript. What better than to have the machine responsible for evaluating and executing our code to first analyze and check its validity before we even consider going to our browser to see if everything's working. So, what is TypeScript? TypeScript is Microsoft's solution to large-scale JavaScript development. It's a compiled language whose syntax is entirely based on JavaScript and builds up on it with additional constructions. It's free, it's open source, and it can be used to script against any browser. With the help of Node.js, a runtime for desktop execution of JavaScript applications, we can also create applications for any operating system. Lately, we also have frameworks like Apache Cordova or NativeScript that allow us to also write mobile native applications with HTML and JavaScript and in transitivity with TypeScript. On top of all this, we're getting more and more integrated development environments like Visual Studio, Eclipse to support TypeScript as a development plugin and increase our productivity. Considering all of this, we can see that TypeScript can be put to almost any development purpose. However, it can be put to the wrong purpose as well. My first encounter with the tool was just that, wrong. About 3 years ago, in the project I was working on, we had a dream. We wanted to use object-oriented design patterns in our front end to reduce code repetition. We did a brief research and discovered a newly released TypeScript language, which had the ability to turn class-like syntax, like the one we're seeing, into working JavaScript code. Sadly, we weren't given the opportunity to use the TypeScript compiler itself, so we decided to do the next best thing, which was to start translating the output manually. The problem with what we've got is that for us, it was unreadable and unmaintainable. You can imagine how many more errors we started having when one of these expressions wasn't written exactly as it should have been. In the end, I thought that TypeScript did us more harm than help. So, why are we here today? And why am I claiming that TypeScript can indeed help us? Because I realized I had missed the point. TypeScript is a tool that has to completely replace writing standard JavaScript. And it does so with the concept hidden in its name, types. With types, we get static typing that we have in other languages, which gives us compile time warnings that expose errors as soon as we write them. As I also mentioned, TypeScript and JavaScript have entirely compatible syntax between each other, so we can migrate all of our existing JavaScript files today and start adding types with little to no overhead. The other most important thing is that we get the concept of interfaces and classes, so we can actually implement object-oriented design patterns in our front end more easily. And we shouldn't care that the output we saw is unreadable in some cases, because this is the only implementation possible in ECMAScript 5. But in ECMAScript 6, the syntax for classes in JavaScript and TypeScript is going to be exactly alike. Which brings us to the last point. The TypeScript compiler gives us the promise that we can change the compilation level for the ECMAScript standard at any time. So currently, we ought to keep this at ECMAScript 5 because most browsers can only interpret such code. But when ECMAScript 6 becomes the de facto standard, we can easily switch to it and benefit from the possible optimizations. Before we jump into the demo, I want to cover some of the basic syntax in TypeScript and mainly the type definition. Unlike most type languages, where the type name precedes the variable name, in TypeScript, this is after the variable name separated by a colon. The primitive types are the same ones we have in JavaScript: Boolean, number, string, array, and object. And we also have the void keyword, which allows us to define functions that have no return type at all. We're not limited to primitive types, of course. We can have more complex structures, like function signatures, which consist of arguments and its return value. The arguments are nested within brackets and separated by commas, and each of the arguments can also have its own type. The arrow then points to the return type of the function. Next up, we have structural definitions, which we can define as giving an object its shape of properties that it's going to have. This is especially useful in cases where we want to have an object that's going to consist of multiple options that our functions are going to use. And as you can see in the example, we have misspelled the property, and the compiler is going to give us a warning about this. Lastly, we have all built-in JavaScript objects, and any classes that we have defined also represented as types. So the TypeScript compiler is actually going to give us all of the API for date objects and regular expressions, and we won't have to go read on the documentation online. But the most interesting and curious type of all types in TypeScript is the anytype. Because in TypeScript, variables automatically infer the type of the value that we set initially. Like in the first example, this is going to be a number. We may have a case where we later reuse this variable with another type. In this case, the migrated file is going to give us compile warning, and the only way we can work around this is to explicitly set the variable as any. As we can see, it then starts behaving like a normal JavaScript variable. But the interesting part here is that not only we can set any type of value to this variable, we can also give it as any other type that is expected in the system. So in the second example, we can see that we have a function that expects a string, but we can force it to get a number. There is There are quite a few more constructions in the TypeScript language that have been built upon the JavaScript syntax, but we're not going to cover them all in depth. It's interesting that most of them are actually planned ECMAScript 6 features like fat arrow functions and classes. So let's start with the demonstration. The first one is, I think, the most important one. It's about how to take an existing JavaScript application and turn it into a TypeScript compiled application. To make things more interesting, I decided to make this demonstration not in Visual Studio, but in Eclipse, the Eclipse development environment. So I have already opened it. The first two things we have to do, because unlike in Visual Studio, not everything is set up ahead of time, we have to install Node.js on our machine where we're going to develop, because the JavaScript compiler requires it as a runtime. Once we have this done, I already have it, apparently, we can go to the Eclipse marketplace and search for the TypeScript plugin. Okay, I think the connection is a bit slow. Excuse me. So the first search result we're going to get is actually the plugin that we are going to use, as long as it shows up. Yes, here it is. So I have this installed as well. We then have to have an application that we want to migrate. In my case, I have written this small app, which represents an animated clock in the browser. So I'm going to run it. I think I ran the wrong file. Perfect. Okay, it should start now. So, here's the clock. It's not a complex application as I would have wanted to show, but it should help us illustrate the most important things in TypeScript. One thing I'm noticing is that the time is incorrect. We have to see what's going on. We can pause the clock by using this button, and we also have functionality to change the... Okay, we don't have functionality to change the hours. So let's see what's going on. Our JavaScript file looks fine. In Eclipse, we're not going to see anything more than we already have. And to be honest, I don't want to go to the browser to see what the errors are. Apparently, we're going to catch them that way. But we want to demonstrate if there's an easier way. I'm going to duplicate this project, and I'm going to rename it to TypeScript clock. One more step that I need to do in Eclipse is to enable the TypeScript builder, because it's not a built-in feature in the development environment. I can then go to the JavaScript resource and rename it to change the extension to TS for TypeScript. You may notice that we get another JavaScript file inside, because the compiler automatically compiled the new TypeScript file and output the necessary JavaScript. So it's the same as the one we had so far. And let's open the TypeScript file, because that's where the fun starts. We can immediately see that we're already having some kinds of errors shown in the development environment, and we're going to go one by one to see what they are. So at the bottom here, in Eclipse, we can see that the first one is that we cannot find the name $. Many of you, I presume, already know that this is the jQuery function, and the thing is that TypeScript does not know about jQuery because it's a third-party library. TypeScript only knows about the built-in objects in JavaScript. So to tell TypeScript to recognize it, we have definition files into the system that we can use to remove this error. So I'm going to import a definition file for the whole jQuery library, and it's going to tell the compiler what exactly jQuery has to offer. So I can open the file that represents the definition for jQuery, and we can see that nowhere inside are any kinds of implementations. So this file will not take care of implementing and defining jQuery. It's only going to do its purpose to tell the compiler what jQuery is. And we can see how this is going to benefit us in a bit. The first benefit is that we stopped having the compiler warning that the dollar function is undefined, and we started having other stuff. So let's see what's going on here. First of all, this is a polyfill. I guess most of you know about this practice. We want to have the request animation frame to be defined on any browser that we open, and in the worst case, we're going to use set timeout to make the animation possible. However, the compiler is telling us that we have a function that returns void, but it's not assignable to a type that expects the return type to be a number. So what's going on here is that the last polyfill, which is using set timeout, actually doesn't return the ID that we need to cancel the animation. So this is a bug that we would have caught only if we run this code in a browser that didn't support any of the animation frame functions, for example, Internet Explorer 8. And then we had to debug why we're not able to cancel it, see that we're getting an undefined result, and then see that we are missing the return statement. But the compiler warned us that we missed something much, much sooner. The next error is, I think, the most common one. We have a function that has an argument, and inside the function, we use the argument, but the names are so alike that we miss that we have misspelled it and we're missing an S. So I'm betting that this is the reason why our adding of hours and removing of hours button was not working. The second most common error that we're going to have when we're migrating is when we are reusing variables set with an initial value and then setting another type of value, as we discussed. The easiest solution here is to use the any type. However, this is also dangerous because from here on, this variable is not going to behave the way it should be. It's going to be dynamic again. And the last mistake, it seems that I'm sloppy and I tend to mix up the variable names in any kind of way. And the compiler is telling me that currently this option in the CSS that I want to set is also incorrect. And with this, I think that all of the errors are gone. So we can run again the application and see if anything is fixed. Okay, I had to clear the cache. So we can see that we're showing the correct time. The clock is working, and we can shift hours back and forth. Before we end though, there's one more thing that we can do. Let's add types everywhere to make the code a bit safer for the future. So here we have a few jQuery objects. We can define them like this. This one is a number, Boolean. And let's set the return types of all functions. I think most of them are void, so I'm just going to make them void. We can also give the argument here a type as well. This is a string, another jQuery object. Casing is important. Date. So do you want to leave this as any type, or do you want me to remove this? Let's remove it. I am personally not a fan of the any. I only use it as a shortcut in some situations. So let's treat it as a number. And I'm actually going to put this inline at the place where it is used. Okay. And we got one more error. It seems that I'm expecting that the setTime function shouldn't return anything, but I had some kind of return. Maybe I was debugging and I needed to see what this value was and forgot to remove it. But to check if I'm correct, I can find all references of this function and see that indeed nowhere do we have an assignment of its returned value. So we can treat it as a void function safely and remove this return statement. Before we end, let's see that everything is working correctly one last time. Shifting hours is okay, pausing is okay. Great. So, to make a quick recap of what we did, in order to use TypeScript for our development, we first had to install the plugin in Eclipse and the Node.js runtime. If you were using Visual Studio 2015, for example, this step is optional because this is already built in. We then changed all the JavaScript files to TypeScript ones. In my case, I only had one. In a real case scenario, we're going to have much, much more. And the tricky part when we're changing this is that we want to first change the JavaScript files that have no other dependencies to other JavaScript files. And then build from that point on until all of the JavaScript files have been changed. The next step that we have to do is to add definition files for all the third-party libraries that we use. Just want to quickly show here that this is the homepage of the Definitely Type project. It contains many, many definitions for all the third-party libraries. So this is a good starting point for searching before implementing them ourselves, because this may take a lot more time. We then fixed the variables that were used incorrectly, mistyped, or used with multiple types, caught all invalid function calls, and properties in objects that were misspelled as well. And we lastly added types everywhere to make the code safer in the long run. The next demo is going to build upon this application with more of the advanced constructs in TypeScript to see how they can help us reuse and structure our code logic a bit better. So what is going to happen if I receive the following requirement? My boss wants me to have a second clock that is going to show another time zone for their client. Okay, well, I'm going to try my luck, open the HTML, copy-paste it, and see what happens. Great. I have two clocks, and let's see if I can set the time zone separately. Nope. Let's see if I can pause. Okay, at least I can pause, but it pauses both of them. This is a bit inconvenient, and the reason for this is that the code for this widget was written as a global implementation. So if I want to reuse it, I have to refactor the code. The best way to do this in TypeScript is to use classes. So in this file, I'm going to start implementing a class named clock and migrate all of the global variables that we had into it. So this way I can define fields in the class, as in most programming languages that have object-oriented patterns. I can also not write the public keyword, because by default, it's going to be public. So this takes care of all of the behavioral variables. But this class is not going to contain only data. We wanted to have some kind of behavior. Therefore, we need to migrate the functions as well. The first thing we notice is that inside the class, we have the field active, but when we migrated the function, it tells us that it's not okay with that. The reason for this, the TypeScript compiler insists on using this keyword in all of the method implementations. So we have to add it everywhere that we have. Okay, This is going to need this as well. Maybe I need to copy it to make this faster. Right, so we added this function. I think there's one or two more, so it won't take much longer. All right, I think that's it. We now have a class that can contain all of these properties that we had and all these functions. And hopefully we can reuse it for the second clock. Actually, we're going to need one more method that we are going to define, which is going to start the animation, because currently the animation was started as soon as the JavaScript file was finished evaluating. So we no longer have any global code, which is very well. Does any one of you know that why we're going to have an error or problem with this line of code? If you have used the set timeout functions and request animation frame functions with a function that depends on the this context, you may know that when this function is actually executed, the this context will no longer be what we want it to be. It's going to be the window. So one of the two ways to fix this problem before we encounter it is to bind this function before we pass it with the this of the current function. But there's one more interesting way we can achieve this, because we have this call one more time. We can use the fat arrow functions that I mentioned that are going to be part of the ECMAScript syntax. Their behavior is that they save the this contexts of the place where they're created as well. The interesting bit here is how is this being implemented in ECMAScript 5 before this even happens in ECMAScript 6. We can go to the code that is generated and see. So we can see that it has used the classical function statement, but has changed the this variable inside of it with the one that is preserved before creating it. So these are the two ways that you can preserve the this context in TypeScript. Because the dangerous thing about bind is that it's kind of a modern function in JavaScript and may not work on older browsers. All right. So we created a class, but we don't assume that this definition is going to automatically start our widget. We have to, of course, create an instance. Let's name it clock1. And another one for the second clock. And then we have to also tell each of these clocks to start. Okay, is it working? No, the animation is broken for some reason. And also none of the buttons are working. Great. Well, we have to see what's going on. First of all, in our HTML file, we're using inline handlers for the buttons, which meant that these buttons depended on the global functions that we previously had, but we are now using instance methods inside our clocks. So we have to change them here as well. Copy it again. Now maybe some of you have some feelings about me using inline handlers. I'm not a big fan of them as well, but for the purpose of this demo, I decided that it's going to be the easiest. Okay. So at least the buttons are now working, but we're still sharing the clocks. What's going on? Well, when I copy-pasted the HTML code, I did an error that I assumed that we don't have any elements that are unique, but we actually do. We have to change the ID of the widgets so that we can differentiate between the elements inside the HTML. But what does this mean? Inside our class, we depend that this ID is going to be live clock, and now we have to have a different ID for each of the clocks that we have. So we have to define a constructor. And we're going to initialize the root. And here I'm tempted to use one of the features that's going to be in ECMAScript 6 as well, is string interpolation. Instead of writing our quoted text, I can use this accent symbol to open a string interpolation expression, and inside write a string as I should. So let's do it like this. Or no, actually, we're going to pass live clock as well. So if I want to nest a variable inside the string, I can use this dollar and curly brackets, and inside them tell the name of the variable that I want. And let's see what happens in the JavaScript code is that actually we're having the classic string concatenation. But in our TypeScript code, I think this is a bit more readable because we don't have to tear our string into pieces and add them to each other. So I can do this here as well. Let me just copy it. And I need to nest this sub-selector. And then remove the initial values because they're now redundant. Now we're having errors where we create the clocks. Because we now have to pass this variable in order to construct the instance. I'm a bit concerned that my seconds arrow is not moving, but you can see this in a bit. Let's first see that we're able to manipulate both of the clocks separately. So now we can see that we are only changing time for the first one, and here we're changing the time for the second one. However, let me try this. I'm going to use fat arrow function in both places and see if this helps. Not really, because I'm not executing it. Okay, still nothing. Great. Well, we have to go back to old school. Open the application in our browser and see what's going on. So I'm going to put a breakpoint here and see if we're entering it. And the answer is no. So probably there's something wrong here. Well, it should be calling it here after we set the time. That's why I'm looking at the call stack. So if I continue, and it stops. Very strange. Okay, let's try then. Oh, I made this mistake here as well. I didn't invoke the function in the anonymous function that I created, so it wasn't actually being called, it was just being referenced. Great. Remove the breakpoint, and voila, it's working. Okay, so now I have a second requirement from my boss. He wants me, the second clock, to not be analogous, to have the seconds hand moving all the time. He wants it to move at increments. like a normal clock. And I can make one thing. I can copy this class, paste it, and do the necessary changes that are going to make it possible. However, I want to use object-oriented code here, so I'm going to only extract the logic responsible for creating the seconds and override it in a child class. So the logic I'm looking for is this expression. I'm going to replace it with another method that is not yet defined. For example, getSeconds. And for this method, I'm going to need an access to the current date instance that we have defined here. I can then proceed to define it as a protected method. Like so. And return the expression that we cut. Let's see that everything is working. Okay, so far so good. The second step that I want to make is to create another class. Let's call it stepClock, which is going to extend on the first one. And the only thing that I need to do here is to copy this definition and to make it act like a normal clock, I'm going to round it down to the lower boundary without decimals of the original function by invoking it through the super keyword, getSeconds. And all that I need to do now is to change the construction of the second clock to invoke the second type. And here it is, working like a charm. I'm a bit concerned though that all of my logic is still contained in one file. I want to break it up a bit. And I think we have some time to do this as well. So suppose that I want to create a file that is going to be responsible for the application level of this application. So I can create a new TypeScript file and use a namespace called, for example, application. Inside the namespace, I want to have exactly this logic. The construction of both clocks and their start. However, this file will not know about this class unless I add a reference link, which is, if you have used Visual Studio IntelliSense for JavaScript, you should be familiar with this syntax. I actually forget it every time, but thankfully, we have it on the home page of Definitely Typed. So it's a pseudo comment with XML syntax in which I can give the path of the file that I want to reference. So in this case, it's going to be clock.ts, which is going to contain only the definitions for the classes of the clocks. However, now my application is broken because in the HTML file, we're only referencing the original JavaScript file. And the application is in a separate file. What we can do is we can add another reference here to the compiled file for the application. Or we can tell the compiler that we want to have all of the sources generated into one single file. To do this in Eclipse, we can tinker in the settings for the project. And in the output file name, if we write the correct folder, I think this was the correct slash. We should have, yes, here it is. The application file is appended where it should be, because it's very important that this definition is after we have defined the classes, otherwise we're going to have a runtime error during evaluation. So the compiler automatically joined all of the files and in the correct order. This is once again going to break my inline behavior handlers, because we're no longer dealing with the global clock1 object. We put it in the namespace, so we also have to append the name of the namespace here as well. I really should have done this with at handlers in the code and not in line, sorry. Okay, so let's check our clocks again. Not there. Okay. I missed one thing in the application namespace. Everything, because this is actually implemented as a module in JavaScript, if we want to make something public inside this module, we have to also say that we want to export it. Otherwise, it's going to be truly private inside this module and only be usable within these two brackets. But when we say export, we can now access it the way I want it to access in the inline handlers. Okay, so we can see that we no longer have this undefined variable name problem. And I think that's it about this demo as well. So I have compiled a list of a few resources that we can review if you're interested in using TypeScript. The first one is the official Microsoft handbook describing all the constructions inside of the TypeScript syntax. The second is another presentation by a colleague, Ben Smith, which also presents the same topic in another way. You may find it useful to review it as well. But more importantly, I think, is I don't want to pressure you into thinking that TypeScript is the only solution available. There are many, many code converters, as Andre said, that exist already, and we can use them. And I have found this link where we have 40 or 50 different implementations of code converters for JavaScript. So you can go there, review them one by one, and choose the correct one for you. But if you have chosen to use TypeScript, then you'll definitely find the definitely typed project to be very useful, because it will take care of definitions that you're going to need for third-party libraries. And we have reached the time for questions.